All right, this is problem 21. This one is going to go back to S8, graphing quadratic equations, or graphing polynomial equations. It says identify all points where the graph of h of x equals blah, 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 intersects the x-axis. So, intersects the x-axis, that means we're looking for x-intercepts. Easiest way to do this problem would be plug it into your calculator, plug it into Desmos, and look for the x-intercepts. Look for the spots where it crosses the x-axis. Another way to think about that, the x-intercepts are where y equals 0, right? And you notice all these points that they give you to choose from are all have y equals 0. So we're just looking for what is going to turn this whole thing into 0. So we can think of this as x plus 1 times x squared plus 8x plus 16 equals 0. This is partly factored already, right? We've got the x plus 1 out there. This part right here, x squared plus 8x plus 16, is a quadratic trinomial. So we're looking for what times what gives me 16. That adds up to 8, and it's 4 times 4. So we can continue, if we can factor this part here, this expression, and get x plus 4 times x plus 4. And then the question is, what values of x are going to turn this into 0? Well, x equals negative 1, we'll turn this into 0. X equals negative 4, we'll turn either of these into 0. So those are our two x-intercepts. If you graph it, so those are our two x-intercepts, which means that it will intersect the x-axis at negative 1, 0 and negative 4, 0. Just a reminder, this part here where we have this double 0, right? It hits that negative 4 shows up twice. That means that when we graph it, it's going to look something like this. Negative 4 is right here. Negative 1 is right here. It's going to come and bounce off the x-axis, then come back down, and then go through the x-axis at negative 1. You can graph it and see that. But anyway, negative 4, 0, and oops, not that one. Negative 1, 0 will be our solutions.